Thermodynamics and Kinetics. In order to understand the energy changes that is taking place in a reaction, such as the electrophilic addition reaction of an alkene, then we have to understand some of the basic concepts in both thermodynamics and kinetics. Now, what is thermodynamics going to tell us? The thermodynamics is going to tell us about the reaction at equilibrium. Whereas kinetics is going to tell us about the rate of the reaction. Let's consider a reaction where Y is converted into Z. So the thermodynamics of this reaction is going to tell us the relative amounts of Y and Z present at equilibrium. Whereas kinetics is going to tell us how fast Z is formed from Y. Reaction coordinate diagram. A reaction coordinate diagram is going to help us to determine the energy changes that takes place in each step of the reaction. In a reaction coordinate diagram, the total energy of the species of all the species is plotted in the y-axis, and the progress of the reaction is plotted in the x-axis. And the energy of the reactants is plotted in the left side of the reaction coordinate diagram, and the energy of the products is plotted on the right side of the reaction. Here is the reaction coordinate for a typical reaction between A, B, and C to give the products A and BC. Now, as the reactants are converted into products, the reaction is going to pass through a maximum energy state, which is called as the transition state. And the structure of the transition state is between the structure of the reactants and the products, where some of the bonds are partially formed and some of the bonds are partially broken. The height of the transition state, which is basically the energy difference between the reactants and the products, is going to determine whether a particular reaction can happen or not. If this height is too great, then probably the reaction may not happen and it will not lead to the formation of products. Exergonic and endergonic reaction. A reaction in which the products are more stable than the reactants is said to be an exergonic reaction. In the exergonic reaction, the products are going to have lower energy compared to that of the reactants. Here, the K equilibrium is going to be greater than 1. And delta G is going to be negative. In the endergonic reaction, the products are going to have higher energy compared to that of the reactants, and therefore they are unstable. The K equilibrium is going to be lesser than 1, and delta G is going to be positive. Catalyst. There are some reactions for which we have to add a catalyst. A catalyst is going to simply provide a pathway for a reaction with lower energy barrier. Say, for example, some of the reactions may require a very high energy barrier, and there may not be sufficient energy to climb up the energy barrier in order to form the products. So in such cases, the catalyst is going to pull down the energy barrier so it can easily form the products. So we have to keep in mind that the catalyst is not going to change the energy of the standing point or the energy of the end point. So basically, it's not going to do anything to the energy of the products or the reactants. It's simply going to pull down the energy barrier. So to begin with, it was super high, but with the use of the catalyst, it can be brought down to some extent, so the reaction can be done easily.